Chapter 7, Section 7.1, matrices and system of equation. Matrices is another method to use to solve a linear equations, like 2 equation, 2 variables, 3 equation, 3 variables, 4 equation, 4 variable, and so on. And so we use the matrix method to solve those. Now, definition of matrix is if m and m are positive integers, then m times n is a rectangular array. So matrix is a rectangular array, and this array, you have number of rows, you call number of rows first, and then number of the column. See, row 1, row 2, row 3, row n, column 1, column 2. So for instance, if you want to read or call this matrices here, how many rows do we have? 1, 2, 3. So this is 3. And how many columns? 1, 2. So this one consider as 3 by 2. You always name the number of rows first. 1, 2, 3, 1, 2. The second one, this is a square one. You have 2 rows and 2 columns. So it would be 2 by 2. This one, you have only 1 row, but 4 columns. So it's 1 by 4. And the last one is just 1 entry, right? So it's 1 by 1. That's how to read or find dimension of the matrix. Like here, how many rows? 1, 2. So you write the number of rows first, and how many columns? 3. When you have equations such as this, all the coefficients of the variables are, these are the numbers that you enter into the matrix. So a matrix derived from a system of linear equation, each written in standard form with a constant term on the right, is the augmented matrix of the system. So what you do is you list all the numbers or all the coefficients or the numbers sitting next to each variables. Like here, what number is sitting next to x? 1, -4, 3, 1, -4, 3. And numbers on the right side of the equation, you list them all here, and you put this broken line here. So what's the coefficient? What's the number sitting next to x? -1. Y is 3, -1, and -3, and so on. So when you have in this example, so what you need to do, if you want to list all the entries, what you need to do is you have to line up all the variables. Like if it's x, y should not be under x. So you line up all the variables first, like here. The one that are missing in each equation or each line, you just leave it blank. Or you could sometimes write a 0 times, like here, x plus 3y, z is missing, right? If you want, you could just put plus 0, z minus w. Everything listed. But when you want to list the numbers here, the one that they're missing, like here, z is missing, right? It was plus 0, 0 times z, you just put that 0 here. Like this one, x is missing. You could put 0x, so what's coefficient of x? 0, you put that here. That's how you write all the numbers. Like on this one, see, 1, 1, 1, 2. 2, -1, 3, -1. -1, 2, -1, 4. There are so many things you could do with the matrices, like you could interchange an equation, you could multiply one equations, you could add a multiple of equations. Like here, you have this is your original, right? What you could do, you could interchange these two. You could take all these, put in the top, and all this, the first row, and put in the second. You could do that. you could multiply the first one by half. See, our goal is eventually to get to this point. See here? When you reach to this point, then you have, when you put the variables back, you have two, like y and z in this equation and y and z in this equation. See, these two would be two equations, two variables you could solve. But they want to show you that, like here, to create a new row here, we take the second one, multiply by -2 plus the R3, that would give you the third one. Now, like in this one, see, if you look at the final answer here, look at this one. If you want to put all the letters back, if you put the x here and y here and z here equal to 2, that gives you equation with one variables. This is our goal. Like here, if you put x here, y here, and numbers on the other side, that gives you these equations. So our goal is to have the last row at least 2 0 here and just one number. The second one, at least 1 0. So you come up with two variables, and the first one is okay. You don't have to have 0 here. So like here, first I try to, in this one, I want to create a new R2. To create new R2, they're saying take R1 and R2 add together. That gives you the new R2. Like, look, R1 is this: 1, -2, 3, and 9. And R2, it said add R1 and R2, right? So R2 is -1, 3, 0, -4. They're saying that add R1 to R2 to come up with the new R2. So the new R2 would be 0, 1, 3, and 5. See, that's what they have here. And then here they are saying take R1, multiply by -2, and then add it to R3. Okay. See, they're saying take, let me see, right now R2 is 0, 1, 3, and 5. Okay. They're saying take R, and then R1 is 1, -2, 3, and 9. They're saying take R1 and multiply by -2. This R1, multiply everything by -2. So it would be what? -2 R1 is 4, -6, -8. So this is a new one, right? -2 R1. Then they say add it to R3. So let's just put R3 here. R3 is 2, -5, 5, and 17. So when you do that, the new one is R3. This is a new R3 when you do that. Okay. So, and then take R2 and R3, that would be new R3. So you end up having something like this, and then that would give you the numbers. You know, it's very easy if you understand how to use the calculator and at least to verify your answers and solve this. I'll show you an example here how to use the calculator for that. in this example, you have 3 equations and 3 variables, right? So, so what we need to do here is first, let's see. They're saying go to the second matrix. And so this is the second matrix. And then when you do that, your matrix is 3 by 4, right? 1, 2, 3, 1, 2, 3, 4. So, so go to edit and put 3 by 4. Okay, when you do that, then enter. Now put the numbers. 1, enter, 1, enter, 1, enter, 2, enter, -3, enter, 1, enter, 1, enter, 0, enter, 2, enter. Let me see if I have all the numbers correctly. This was 4. That was 2. -3. 1. That was 13. Oops. Sorry about that. I don't know why it doesn't. There is this. I don't know why it doesn't erase the last one. Oh. Okay. All right. So, and then he said, now when you're done, go to second matrix and then go to math again. So, and scroll down to this one. and then select A. Go to second matrix, enter, and then enter. Anyway, these are the numbers. I don't know what I did. I don't want to waste the time. But anyway, and then if you want to erase it, you could actually go to erase a matrix. You could follow this. You just go like here. I want to go ahead and do it again. You go to the second and then plus, and then go to number 2, the memory. You want to erase it. And then you just want to erase the matrix. You go here and erase your matrix. Okay, delete. All right, sorry about that. So, all right, so here, and then now they also show you, then they have row echelon form and reduce row echelon form. And this is a special type of matrix that at the end, you have 0 on the last one. Okay, and when we ask you to find the reduced row echelon form, because every column has reading 1, so that when you find the final answers, the very first number, which is heading that row, has to have 1. And so it has 1, this one has 1, and the last row is 0. This is a special type of matrix that if you want to do, you have to follow all this. You know, any rows consist entirely of 0 at the bottom. Each row does not consist entirely 0. And the first non-zero entry is 1. For 2 non-zero row, leading is 1 is the higher. I don't know if you have any homework for that one. Again, this is another elimination. This is 4. So you understand, see how at the end, you should come up with all this 0 here. This is all 1 and this is 0. When the last one has 3 0 and 1 number, then that would, if you put your variable here, x, y, z, and w, then that just give you the w here. Or here, there are just 2 variables, right? Because the first 2 is 0. So it would be z minus w. The third one has only 3 variables. And the last one. So one by one, you take this w, you put it here, you find the z, you take z and w, you put it here to find the y, and then you put it here to find the x. But again, if you understand how to use the calculator, it's very easy to solve problems. They all are very similar. Sometimes there is a matrix that you don't end up solving it. And see, right here, you do all the work, and in the end, you cannot just come up with the right answers. Okay, and then so it's easier if you use your calculator. The calculator will tell you whether it's correct or not. And this is Larson and Gauss-Jordan eliminations. This is again another 3 equations and 3 variables. His method also is you want to end up something like this. See, there is a 1 here and 0 here. And this is another example that I show you how to use a calculator. Like these problems. This is for example 8. So this example 8 that you see here, all this, I did it here for you. So this is basically 1, 2, 3, 4, 1, 2, 3, 4, 5. It's a 4 by 5 matrix. And these are the numbers that we came up with. So what you have, this is example 8, okay? Which is just 1, 2, 3, and 3 row and 4 columns. This is another example that I put these numbers here to show you how to use the calculator for this one. This has nothing to do with the example, but just show you how to do it for 1, 2, 3, 4 by 5, 4 row by 5 columns, how to use it, the calculator for it. Sometimes you may end up having equation that is just 2 equations and 3 variables. In that case, when you solve it, you can actually get the actual number for x and y, z, but both x and y has to have a parameter of z in it. So what we do is instead of, here, when we find the x from the top one and y from the bottom one, and then what you do instead of the letter of z, you could take one of the letter like z and you put a. It's like now you have 2 equations and 2 variables. It's just your equation, it has instead of number, it has a number plus a. Okay, so what happened is your answer has a in it. So this is a case, again, you have, since you do, number of equation must always match number of variables. But if you have 2 equation and 3 variables, you cannot do it. So what you do is you assume that this z is just the letter a. Okay, and that's how you solve. All right, so the rest would be your homework.